Was führt Sie denn zu uns?
After successfully completed systematic periodontal treatment, the patient wants functional prosthetic restoration. The therapeutic possibilities are discussed. The anamnesis is requested and analyzed before the treatment is started. Alternative suggestions are considered and the various possible constructions discussed. The aim of the treatment is to restore the masticatory function as an important prerequisite for the oral well-being of the patient. A detailed record of the findings is available at the start of the prosthetic restoration. It provides all of the data required for effective planning of the dental measures now to be adopted and the technology involved. Particularly striking is the large anterior edentulous gap in the upper arch and the gap in the posterior dentition. The healthy color of the mucosa shows clearly that the periodontal treatment was successful. An edentulous gap can be recognized in the posterior area. All of the molars are missing on the other side. Taking a careful impression of the area for the free end saddle allows the prosthesis to be extended over a large area, later for secure gingival support. Patient and dentist agree on cobalt chrome class prostheses. Diagnostic models should always be made to enable better planning. Alginates form very suitable impression materials. The alginate reproduces the moist mucosa very accurately, even under compression. Myostatic impressions have proven very effective for the sublingual area. The patient must not move his tongue while they are being taken. The floor of the mouth is represented so that the bar can be placed on it in a prophylactically appropriate manner. The upper arch is a Kennedy class 1, that is, a situation with bilateral edentulous areas posterior to the remaining teeth. The additional anterior gap gives an index of 1. The design of the base in the anterior area is a compromise between periodontal prophylaxis and good conditions for speech. This is a Kennedy Class 2 Index 1 situation.
Das bedeutet, dass wir einmal eine verkürzte Zahnreihe haben und eine zusätzliche Unterbrechung.
The gap between the second premolar and second molar is filled by a tooth-supported saddle and the natural dentition, with posterior edentulous space on the other side of the arch is provided with a free-end saddle. Connect the two prosthesis saddles rigidly. Try to get a periodontally and prophylactically effective arrangement of the sublingual bar. The saddle dynamics determine the design of the free end saddle. The large extension of the saddle reduces sinking. Do not load the distal third. Use tooth supports for the mesial saddle area. Position the rest mesio-occlusally. Diagnostic models alone are not sufficient to determine the bite. A bite registration must be provided. Small corrections of the occlusal rims are always required. In this case, the height of the occlusal rims must be reduced to get small, clearly recognizable impressions of the antagonists. The hot wax knife is used to melt and smooth the surface. The patient is able to occlude the dentition with a minimum of effort. Small, clearly recognizable impressions have resulted in the intercuspidation. The upper and lower bite plates are on the models again. This enables the models to be fixed reliably in relation to each other. The models have now been articulated using the split cast method. The oral situation can be evaluated extremely well from this view. The close spacing of the remaining teeth is clear, important information for subsequent planning. It is evident that functional and cosmetic needs are not easily reconciled here. The next step is surveying. Diagnostic surveying, that is, the initial analysis of the model, is an extremely important task the dentist has to carry out. The retention capabilities of the remaining dentition cannot be adequately determined without a surveying instrument. The model secured on the table is therefore measured in the 0 position. The best direction for inserting the cobalt chrome prosthesis is to be found with the surveying instrument after ney. Tilting the table accordingly decreases or increases the retention area on the tooth. The critical free end situation on both sides necessitates secure anchoring of the prosthesis on the remaining dentition. An undercut of 0.5 mm is therefore required. The dentist marks the undercut accurately on the tooth. The direction of insertion is defined. The position of the table remains unaltered. The requirement of an 0.5 mm undercut is satisfied. The rim and shank of the undercut gauge touch the plaster tooth simultaneously. The infradental convexity and subsequent retention area of the clasp are easily recognized. Surveying the diagnostic model is just as important as the definitive survey of the master models. Diagnostic surveying accurately defines the positions that have to be ground. From now on, the position of model on the table must not be altered anymore. The height of contour is marked in the specified direction of insertion. The graphite rod marks the greatest circumference of the teeth in the remaining dentition, that is, the height of contour or design equator. It divides the clasp tooth into 2 areas. All of the rigid parts of the clasp subsequently lie on or above the line marked. Flexible sections of the clasp are in the retention area, that is, below the circular marking. The undercut, marked in red, is clearly recognizable. The clasp subsequently reaches its lowest point here. The models are in the articulator again. There's only a limited amount of space available in the anterior and incisal areas. Clasps are planned for these positions. The line of contour is well towards the incisal plane to enable accommodation of passive clasp parts. The close dentition is easily recognized from this angle. The corresponding support surfaces and clasped curves are now to be determined. If there is not enough space to position clasps and rests, preparation must be carried out on the tooth. The dentist first makes this correction on the plaster model with a sharp spatula. Here he can clearly recognize how much tooth structure has to be removed. This shifts the line of contour slightly towards the cervical area, allowing rigid clasp parts to be fitted. The areas from which material has been removed from the plaster model are marked. This gives a guide surface on the tooth. It simplifies insertion and removal of the prosthesis. The altered position of the height of contour allows an unobtrusive yet effective retainer to be fitted mesially on the second incisor without hindering occlusion. Preparation of the tooth allows a lower and more favorable position of the contour of clasp. Marking the prepared surfaces helps a great deal. The dentist marks the construction of the cobalt chrome base on the diagnostic model. All of the important features have now been recorded. The provisional clasp curve is indicated. The areas marked in green have to be removed. Periodontal prophylaxis plays an important role in the design of the base. The first tooth to be replaced is designed like a pontic. Only a small area of the metal basal surface comes into contact with the mucosa. Good preparation by the dentist can be recognized from the following features. The height of contour lowered relative to the lingual position on the second premolar. The inclined plane above the line of contour on the second molar. Space for the distal rest and the rigid part of the ring clasp planned. The position of the sublingual bar is determined by periodontal hygiene considerations. A bridge-like design of the first replacement tooth is therefore also a possibility in the region of the first molar. The construction planned and need to correct some teeth by grinding are explained to the patient.
Dann haben wir die Klammern schön tief gelegt, nicht, damit man die gar nicht sieht, wenn Sie die Prothesen tragen. So, und nun fangen wir an zu schleifen.
The preparation is carried out on the tooth similarly to the marking on the model. The extent to which the teeth are ground must be limited to what is necessary. Continual comparison of the situation in the mouth with the marking on the surveyed model helps achieve this. The green marking on the model makes it easier for the dentist to find the corresponding position in the mouth. And another comparison is made. As planned, an inclined plane is provided on the second molar above the height of contour. As a result, the flexible part of the clasp slides smoothly over the infradental convexity. Everything is prepared for taking an impression of the upper arch. The relatively low pressure process of taking an alginate impression has proven very satisfactory in practice. An agent is applied to the inside of the impression tray that allows the alginate to adhere firmly to the tray. Alginates are to be preferred when it is possible to fill the impression immediately. A sufficiently thick layer of alginate is elastic enough to reproduce even undercut areas and the marginal gingiva accurately. The patient breathes through the nose to avoid gagging. Even the slightest movement leads to distortions and hence inaccuracies in the impression. Once in its final position, the impression tray must not be moved anymore. Once the alginate has set, the impression tray only has to be turned slightly to release it from its position without tilting it. The impression is checked, disinfected and filled. And making of the master model begins immediately. Measuring cup and portion bag help eliminate measuring fluctuations. To fully exploit the low expansion and useful period of about 5 minutes for which it remains workable, this super hard plaster should be stored at about 20 degrees Celsius and mixed with water at the same temperature. If no vacuum mixer is available for the plaster in the dental practice, it can be mixed manually instead. The plaster must be mixed evenly for about 60 seconds to be able to get the full benefit of its properties. The impression is filled slowly on a low vibration setting. The compressive strength required is reached after an hour. The impression is removed. The preparatory measures also include a trial fitting of the front teeth, which have been prepared on the articulated diagnostic models. The dentist carries out this trial fitting in the patient's mouth. The replacement teeth fit into the dentition unobtrusively. The bottom lip lies against the bottom third of the upper incisors. The view in the mirror shows the patient is satisfied with the intermediate result. All of the information of importance to the dental technician must form part of the order to the laboratory. It gives accurate specifications about the construction required by the dentist and important details such as shape and extent of the base in the upper arch, quantity and curve of the type of clasp required, dental rest, Pontic-like design of the first replacement on both second premolars, the teeth to be replaced, curve of the bar marked in the lower arch. This information is indispensable for an individual prosthetic solution. In addition to the patient's data and the completion date required, the type of alloy is specified. The dental laboratory is given an order to make the cobalt chrome prostheses. The dentist's diagnostic model is always an important aid for the dental technician. The rests are prepared and the height of contour lowered. The ground areas are marked green. The shape and extent of the base of the prosthesis are accurately marked. The undercut is determined to an accuracy of 1/10 of a millimeter during surveying. Undercut areas are blocked out and the saddle zones covered with preparation wax. Silicone compounds such as Wirosil allow fast yet accurate duplication of the models. The silicone mold is filled with the particularly fine investment material Wiroplus S. The result is an accurate investment model. The wax-up is now provided with sprues. The casting funnel former is waxed onto the sprues with care. After investment, the mold is preheated according to the instructions for use. Casting is carried out with the Nautilus vacuum pressure casting machine. After deflasking and blasting, the sprues are cut off and the attachment points carefully ground. Sintered diamonds are very suitable for finishing cobalt chrome alloys. The subsequent electrolytic polishing improves the surface finish. The cobalt chrome frame is now smoothed with suitable rubber polishers and polished carefully with the blue paste. Impressive work. It conforms in every respect to the order received by the laboratory. The lower frame shows the logical design of the periodontal areas, as becomes particularly clear with this detail. The basal design at the first molar allows good self-cleansing. The rinseable interdental space and pontic-like shape are required for effective prosthesis hygiene. There is sufficient space between the top edge of the bar and the marginal gingiva. The finished cobalt chrome frames are explained to the patient. The upper frame also fulfills the requirements for good periodontal prophylaxis. The ample dorsal extension of the base of the prosthesis improves the gingival support. This pontic-like shape at the second premolar allows effective self-cleansing. The clasp arms lie against the plaster model without any stresses being induced. The tips of the clasps are slightly rounded. The first trial fitting, initially without occlusal rims, is the next step. Premature contacts and interference can only be determined in this way. The clasps and rests lie against the abutment teeth without any gaps. A good example is the clasp at the second premolar. The tooth is held securely and the short arm of the clasp is completely adequate for retention. This solution is a cosmetic success, since the look of the anterior teeth is not spoilt by clasps. The connection from the rest to the saddle must be extremely strong and secure. The strong ring clasp at the second molar meets the need for a rigid connection with the distal rest. The sublingual bar, close to the mucosa, it matches the shape of the arch. This shape does not limit the freedom of movement of the frenum linguae. The prosthesis frames are prepared for registering the bite. The saddle areas have been underlaid with wax and wax rims attached. pairing of the master models is explained with reference to different modeling situations and the work for the patient already shown in Part 1. Planning the tooth replacement is the dentist's job. The detailed impression of the case provides all of the information important for this. The preparation is also important in successful prosthetic restoration. The patient has to be informed about the technically and commercially feasible alternatives. The aim of the treatment is tooth replacement that is effective yet completely unobtrusive. The order the dentist sends to the laboratory forms important documentation on which the dental technician's work is based. The periodontal case and the position of the teeth determine the prosthetic restoration. The order for the laboratory specifies which teeth are intended to be used for rests and clasps. When the edentulous areas are small, the masticatory pressure is transmitted to the remaining teeth. Careful consideration must be given to the specification of the support points. Molars and canines in particular should be used as clasp teeth due to their greater load capacity. Secure support is possible in this example because rests can be fitted either side of the edentulous areas. In addition to the clinical analysis of the remaining dentition, the static and dynamic relations are also important in planning a cobalt chrome prosthesis. Under masticatory pressure, the prosthesis is depressed on the free end saddle. This results in an axis of rotation through the rests. The mesial support of the upper left first premolar is therefore important. Free end saddles are always supported away from the saddle. With this unilateral free end situation, the axis of rotation passes through the mesial rest on the first premolar to the mesial rest on the molar the other side of the arch. Depression of the saddle of the prosthesis results in a longer lever arm. The lever arm runs from the tip of the clasp at upper right first premolar to the axis of rotation. Connecting the rests with the tip of the clasp at rear right first premolar gives a triangular surface. The bigger this area, marked yellow here, the more securely the prosthesis is supported. The length of the lever arm decides the size of the area of application of the load, marked green. The load arm is shortened if one tooth less is set up. This reduces unfavorable leverage on the clasp teeth. A prosthesis with a base that is large in area distributes the lever forces arising significantly better. The saddle of the prosthesis must be extended as far as possible to achieve the maximum possible gingival support. The wide saddle and posterior edentulous area reduce the dorsal sinking of the edge of the prosthesis. The functionally important anterior palatal area is not covered by the prosthesis. The wide and stable transverse base allows a good gingival support. The finishing line should not be positioned too far in the dorsal direction, since the posterior palatal area with its adipose and glandular tissue is not suitable for use as a support surface. The dentist has determined the resilience of the mucosa and specified the size of the base in advance. The dorsal extension depends on the curve of the junction on the roof of the palate between the bone and the mucosa. It can be marked in the patient's mouth and transferred to the model by the impression. The transverse connection is to be preferred to the horseshoe shape. In this case, the width of the transverse connector corresponds to the extent of the natural teeth. It is measured and transferred to the model. The transverse connector is at right angles to the central palatal suture. The extent to which the periodontium is exposed is increased if the first tooth to be replaced is designed like a pontic. The palatal ridge area remains largely exposed. This avoids limiting the massaging effect of the tongue and causing speech impediments. In this case, the minimum gap between the base and the marginal gingiva should not be less than 4 millimeters. In lower arch structures, the major connector is marked sufficiently far away from the periodontium. The minor connector, from the bar to the lingual clasp arm, leaves the interdental space free to facilitate oral hygiene. the pontic-like design of the first tooth of the prosthesis achieves maximum exposure of the periodontium here as well. Only if the floor of the mouth has been adequately reproduced can the sublingual bar be positioned 4 millimeters away from the marginal gingiva. This dental requirement is met in this case. An expert survey is indispensable. It is needed to choose the right clasp. Another important factor is the periodontal condition of the clasp teeth. In this case, the prosthesis can be given adequate periodontal support. E-clasps are provided on the molars and G-clasps on the premolars. The clasps are effective as a result of the support of the retentive clasp arm and the rigid abutment. The E-clasp is mainly indicated in the posterior and for small edentulous areas. The rigid palatal arm acts as an abutment and guides the prosthesis on the clasp tooth when it is being inserted and removed. To improve the stability of the mesial rest with the G-clasp, the minor connector is fitted disto-palatally. This lengthens the active arm of the clasp and its retention capacity is increased. The ring clasp is only indicated on molars and, whenever possible, should be fitted in corresponding positions on both sides of the arch. The back-action clasp has proven effective for lower structures on premolars and molars. The favorable position of the rest relative to the minor connector improves the support here. The Bonwell clasp is suitable for use as a static element with a splint or interlocking function. It can be fitted to the most posterior tooth in the form of a ring clasp. The Roach clasp is indicated in the anterior and posterior areas. There are many other possibilities apart from this traditional type. The minor connector is in lateral contact with the clasp higher above the marginal gingiva. This avoids pressure points. The next step is to survey the master model. Its provisional position in the surveying instrument should correspond to 0. Provided this position is maintained, the patient can insert the prosthesis later under masticatory pressure. The tooth surfaces provided as the retention area can subsequently be traced from mesial to distal with the undercut gauge. The clasp must be retained below the point of contact of the undercut gauge on the tooth. The undercuts are distributed evenly on the load-bearing clasp teeth. The auxiliary line marks the extent to which the clasp is to encircle the tooth. Adequate retention must be available for the clasp within this marked area. Provided this is the case, the undercut required is determined on this auxiliary line. The tooth, particularly if it is the most posterior one, must be sufficiently encompassed by the clasp. To prevent damage to the mucosa when inserting the prosthesis, the molar clasp arm should extend into the distal area as far as possible. The auxiliary line is marked accordingly. An undercut of about ½ millimeter is possible with this tooth. The depth of undercut must now be measured with the appropriate undercut gauge. This involves lowering the undercut gauge until its rim and shank lie against the tooth simultaneously. If bringing the undercut gauge into contact shows the undercut is excessive or insufficient, the model is tilted mesially or distally slightly. We must allow for the extent to which the tooth has loosened, since only the clinically firm tooth can be fully loaded. To avoid irritation of the mucosa, a gap of about 1.5 millimeters must be maintained between the clasp and the marginal gingiva. Working with the parameter achieves greater accuracy. The scale provides a continuous indication of the size of all undercut areas up to 0.8 millimeter. The maximum undercut can be set. An undercut of more than 0.6 millimeter is only acceptable in borderline cases. The continuous measurement allows the undercut depth to be determined significantly more accurately. Once all of the undercut points have been settled, the final direction of insertion of the prosthesis is determined. The position of the model may now no longer be altered. The prosthetic height of contour is marked at this stage. The graphite rod is guided around the tooth without exerting excessive pressure. The direction of insertion determined is to be maintained. It therefore helps to use a surveying instrument whose table can be removed. The form of the clasp is now marked. The clasp reaches its lowest point on the longitudinal marking. The tip of the clasp is inclined slightly upwards to avoid damaging the marginal gingiva when inserting the prosthesis. After about a third of its length, the clasp reaches the height of contour, which it should not fall below from this point on. The area marked green below the prosthetic height of contour is that in which the clasp is retained. The abutment and all of the other rigid parts of the clasp should be on or above the prosthetic height of contour of the tooth. The construction drawing is compared with the dentist's order for the laboratory to make absolutely certain. The markings are now completed. The rigid abutment must be positioned low enough to remain in contact with the tooth when the prosthesis is being removed. Unilateral loading of the tooth is therefore prevented by the bent-up clasp. The model is ready for the preparatory work. To keep the interdental space clear and allow rinsing, blocking out wax is applied to undercut areas and at the junction between the minor connector and the clasp. Wax must not be deposited on the surfaces where the clasps and the rests come into contact with the tooth. To satisfy the need for modern prosthetic hygiene, the surface which will support the sublingual bar is coated sparingly with blocking out wax to prevent pressure points arising subsequently. This is the only way of producing a self-cleansing sublingual bar that allows rinsing even in the case of flat or inclined ridges. The saddle zones are covered with 0.5 millimeter of preparation wax. This keeps the space required for the acrylic free under the retentions. The palatal saddle zone and the tuberosity must be designed so that they can be fully underlaid. The pontic-like design of the first replacement tooth only gives rise to point contact with the mucosa. A sharp demarcation between the saddle of the prosthesis and the base improves mechanical retention of the acrylic and provides a cleaner finish. If no pontic-like rest is provided in the metal for small edentulous regions, these areas of the arch must also be designed so that they can be underlaid. The central palatal suture is covered with a thin layer of wax to avoid pressure points. In the lower arch as well, the saddle is covered with 0.5 millimeter of preparation wax. The thickness of the wax must be maintained when adapting. A sharp demarcation between the preparation wax and the bar is important. To prevent the metal frame being displaced during finishing, small squares are cut out of the preparation wax on the lower free end saddle. This results in direct contact between the cobalt chrome frame and the master model. The prosthesis will only function properly if the form of the clasp is transferred to the investment model extremely accurately. Blocking out wax is therefore applied to all of the teeth encompassed by the clasp below the clasp marking. The path followed by the clasp is then carefully scraped free of wax with the Legrand instrument. The shoulder produced is reproduced on the investment model and shows the exact form of the clasp. We will now summarize the most important steps. In this case of a patient with considerably depleted remaining dentition, large free-end saddles and an additional anterior edentulous area, the prosthesis rotates. This rotation can be countered by designing an extended gingival support and using the corresponding clasps indicated. The anatomical model surveyed by the dentist for a preliminary analysis provides the dental technician with information about the structure planned. The gap between premolar and molar is filled with a tooth-supported saddle and support provided at a distance from the saddle. The posterior edentulous area is provided with a free end saddle. The distal third is not to be loaded. In this case, support is provided on the most posterior tooth at a distance from the saddle, that is, mesially. The definitive survey of the clasped teeth in the dental laboratory is made significantly easier by adopting a systematic approach. Thus, for example, the preliminary analysis with the undercut gauge gives the provisional direction of insertion. The length of the clasp is determined using a longitudinal marking as an auxiliary line. The direction of insertion can be corrected again when determining the depth of the undercut. Once the line of contour has been determined, the form of the clasp is defined and marked in. The wax shoulder transfers the form of the clasp to the investment model. The saddle areas are covered with 0.5 millimeter thick preparation wax and undercut areas blocked out. Combination work requires particular care. The plastic female part of the Ancora rod attachment serves as a spacer. The crowns, which have been veneered with ceramic and milled, are fixed securely on the model. Undercut areas and gaps are blocked out with wax. The plastic female part must be sealed with the top of the male part of the attachment. The gap between female part and model is also filled with wax. Undercut areas must always be blocked out. To prevent any gap arising between female part and metal, the occlusal surface of the attachment must be covered with a thin layer of wax. The area for the sublingual bar is also coated with a thin layer of wax. No wax must get into the female part of the attachment and the milled surface of the crown during this operation. The side of the plastic female part must be kept free from wax. All of the junctions with the primary part are waxed, and the saddles of the prosthesis are underlaid with preparation wax. A small square is cut out here as well to ensure the base of the model is in contact with the master model subsequently. As in this case, the first replacement tooth should be designed like a pontic on the free end saddle. The preparation wax is waxed on to prevent it coming off the model. Duplicating with silicone is more reliable for combination work with millings and interlocking holes. Part 3 of Bego's Cobalt Chrome Technique video covers duplicating in detail. This video shows how from phosphate-bound refractory investment material, a duplicate model is made on which the cobalt chrome frame is modeled, invested and cast. One essential prerequisite for an investment model that accurately reproduces the original is the carefully prepared master model. On this work for the patient, which has already been shown in the first two parts of the video, the clasp teeth are surveyed, saddle zones underlaid and undercut areas blocked out. At the most important points, wax shoulders transfer the position of the clasps to the investment model. Gels as well as silicones are used for duplicating the master models. Duplicating gels are reusable materials consisting mainly of natural products. Their ability to gel and elasticity are determined by the raw material agar-agar. The constituents also include glycerine and water. An electronically controlled duplicating unit helps considerably. The heating raises the temperature of the duplicating gel to 93 degrees Celsius. The built-in fan cools Castogel to 42 degrees Celsius, the ideal temperature for processing clasp prostheses. The lower the temperature, the less the contraction of the duplicating mold. To avoid impairing the quality, new and used duplicating gel should not be mixed. Always wash duplicating gel off under running water and store in an airtight container. The liquid adhering compensates for moisture losses. Before duplication, master models are immersed in cold water for about 3 minutes to avoid air bubbles under the wax saddles when the models are very dry. The master models must then be soaked at 38 degrees Celsius for 5 to 10 minutes. Soaking prevents the dry model drawing moisture out of the duplicating gel, which would give rise to rough investment model surfaces later. There is a danger of the surface of the plaster starting to dissolve if the model is soaked for too long. To prevent the wax saddles coming off, it is better to immerse the models in the water bath upside down. When the bubbles stop rising, the model is removed and dried. When used properly, reusable duplicating materials represent a cost-effective alternative to duplicating silicones. Castogel is characterized by high recovery and excellent elasticity. Guide wedges in the top part of the flask prevent rotation. The negative mold can be reinserted in this way without any problems after removal of the master model. The clear top part of the flask allows you to check that the material is flowing in properly. The duplicating gel should not come into direct contact with the saddles underlaid with preparation wax, since this can cause them to deform or lift off the model. Always cool duplicating gels to room temperature, which may, however, take up to 1.5 hours. By contrast, the built-in flask cooler only needs 60 minutes until the model can be removed. Castogale reproduces so accurately that even combined work can be duplicated. The master models are dried with an absorbent paper and the milled surfaces blown dry. Even such milled surfaces and interlock holes for stabilizers are duplicated accurately. To prevent duplicating gel coming off primary parts, model and gel must be at the same temperature. The duplicating gel is therefore cooled to the required temperature of 38 degrees Celsius. The duplicating gel should always flow in slowly to ensure even critical points are reproduced reliably. The top part of the flask has been pressed onto the base plate firmly. With this base plate, an investment model with base can be made even from large master models. During the subsequent investment, the blue mold former fits exactly on the base produced in this way. To allow the investment material in the area in contact with the duplicating gel to set completely, the duplicating mold must not be cooled in cold water. The result would be rough model surfaces and inaccurate fits. The master models are released and removed from the duplicating mold with care. To rule out deformation of the duplicating gel, the mold is replaced in the top part of the flask for casting. A casting funnel former is used if casting is to be carried out through the model, as in this case. The funnel former, isolated with Vaseline, is easily removed from the investment material later. It is fixed carefully in the middle of the model. 80 parts of Begosol are thinned with 20 parts of distilled water ready for mixing Wiroplus. The duplicating mold is not rinsed or blown out, but filled with Wiroplus immediately. Addition-cured two-component silicones are being used more and more often for techniques demanding maximum accuracy of reproduction. Thanks to the ease with which it flows and its low contraction, Wirosil satisfies this requirement. The investment model is finished significantly faster if silicone is used instead of reversible duplicating gels. The master model must not be soaked when duplicating with silicone. The two components are mixed ready for use with the metering unit. Particularly on milled or polished surfaces and at interlock holes, very accurate reproduction of the primary parts is required. Wirosil reproduces even areas of this type with complete accuracy. The stabilizing insert is not introduced until the dentition is covered. It stiffens the silicone mold in the area of the teeth and palate. the use of an autoclave is appropriate. This forces the silicone even into critical areas at a pressure of 4 bar. The duplicating mold remains in the autoclave during the 30-minute curing period of the silicone. Mixing can of course also be carried out manually if there is no metering unit available. The two components are mixed in the ratio of 1:1 until a uniform light blue color free from streaking is produced. Comminuted used material helps save silicone. To prevent bubbles being entrained in the flow, the silicone is poured in slowly and evenly. The flask is filled up rapidly and the stabilizing insert introduced. The flask is removed from the autoclave after 30 minutes. Silicone that has flowed under the model is removed. Master models that have been carefully blocked out and ground parallel or to a taper can be released from the silicone mold more effectively with controlled amounts of compressed air. Ensure that they are not tilted as they are being removed. The impressive result. All details are reproduced accurately. To prevent deformation of the silicone mold, the flask sleeve is not removed in order to take the master model out, since it cannot be replaced in its original position. The surface tension of the mold is reduced by spraying with orofilm. This makes it easier for the investment material to flow in. To prevent any residues remaining in the silicone mold, it is dried carefully with compressed air after about 30 seconds. The requisite total expansion of the investment material of about 2.2% can be achieved with Wiro Plus S, a very fine special investment material for silicone duplication by using mixing liquid with a concentration of 90%. This concentration can be checked reliably with liquid control. The mixing liquid and the investment material are best kept in a converted fridge or climatic chamber at about 20 degrees Celsius. High temperatures reduce the time the material remains workable, and excessively low temperatures can be the cause of rough surfaces. The mixing liquid is measured out and poured in first. "200 grams of investment material are sufficient for one duplicate model. At a temperature of 20 degrees Celsius, the material remains workable for about 4 minutes. The investment material powder is mixed thoroughly with a spatula for 15 seconds to ensure it is wetted completely. Consistently good results are only achieved by following the instructions for use exactly. When the unit is switched on, the vacuum bowl is evacuated and the mixer switches on after about 3 seconds. With evacuation at the maximum rate, the investment material is mixed in 60 seconds. The Motova SL measures the vacuum between mixing bowl and filter. The pressure gauge therefore shows the actual vacuum in the mixing bowl. The size and shape of the mixer blade are tailored to the mixing bowl. The hose is removed once the vacuum has been released. This keeps the material homogeneous and free from entrained air. The investment material is poured into the duplicating mold with the vibrator on its medium setting. Once all the important sections have been cast, the vibrator is switched off and the duplicating mold filled up without vibration. If, as in this case, the silicone mold is cured at a pressure of 4 bar, then the investment material must also be hardened in the autoclave. This will achieve a smooth surface free from bubbles. After 30 to 40 minutes, the investment model is released with compressed air and removed. Wire Plus S models are dried for 10 minutes at about 80 degrees Celsius. Modeling can be carried out much better on the surface of a warm model. Investment models made in silicone molds do not have to be hardened. Duro fluid modeling spray is sprayed on sparingly before modeling. In the case of models duplicated with gel, at least 40 minutes must be allowed for the investment material to set. The duplicating gel is now removed from the Wire Plus model. These investment models dry for 45 to 60 minutes in the drying cabinet, preheated to 250 degrees Celsius. When the models are dry, they are immersed in the solvent-free and environment-friendly dipping hardener Durol Plus for about 10 seconds. This method of hardening not only produces a harder surface on the model, but also allows the wax-up to adhere to it. The models are dried for about 5 minutes as soon as the excess dipping hardener has drained off. And now to recapitulate the most important points. A perfectly prepared master model. Wax shoulders to transfer the shape of the clasp. Block out all of the undercut areas and underlay saddle zones. Use duplicating materials that ensure accurate reproduction of all the details, and cobalt chrome investment materials that allow good surface finishes and firm edges. Equipment and materials must be tailored to the process technology. The investment model made in this way forms the basis of an accurately fitting cobalt chrome frame. And part 4 of the Bego cobalt chrome video will show modeling used for melting and casting cobalt chrome alloys. This video shows the melting of cobalt chrome alloys with high-frequency induction currents and an open flame, and casting using the centrifugal and vacuum pressure techniques. The crucible, preheated with the muffles, has been placed in the centrifuge for casting in the Fornax 35K. The ingots lie close together for even preheating. A measuring cell registers the infrared radiation emitted by the melting alloy and converts it into an electrical pulse. This pulse controls the induction current to prevent the alloy being overheated during melting. Interrupted preheating, which is also called cycling, allows even melting of the alloy. The muffle, preheated to 1050 degrees Celsius, is now inserted. Melting of the alloy now proceeds rapidly. In the case of wyronium extra hard, centrifuging is started with the lowering of the crucible coil 2 seconds after the shadow disappears from the melt. The centrifuging time is set in the factory. Melting with a flame is an alternative. A mixture of acetylene and oxygen, propane and oxygen, or the natural gas and oxygen used here is suitable. The Fundor T motorized centrifugal casting machine has a continuously adjustable starting speed to enable it to cast different alloys better. The double-jointed arm ensures a high centrifugal force. The counterweight can be adjusted for the mold size without problems. Tinted goggles must always be worn when melting with a flame. The automatic gas igniter helps considerably. When the burner is replaced in the holder after melting, its flame is extinguished without altering the setting. When the casting sequence is rapid, the burner can be reignited with the pilot flame. The burner is guided over the ingots about 6 to 8 centimeters away. This is the only way of heating the alloy, wironite in this case, evenly from the outside to the inside. The moment for casting is reached when the liquid melt moves through the pressure of the flame. For safety reasons, the cover of the machine cannot be opened until the centrifugal arm has come to a standstill. Ongoing development of the casting technique led to the microprocessor-controlled high-frequency vacuum pressure casting machine in the form of the Nautilus MP. The casting program for a specific alloy, wironite extra hard, is being loaded here. Preheating is used with this casting technique as well in order to heat all of the ingots evenly. The preheated muffle is placed in the lower chamber. Once melting has started, the chamber is evacuated and the alloy melted under vacuum. During melting, a microprocessor acting as the central control unit constantly calculates the change with time in the infrared radiation emitted by the alloy. The digital display shows the current information about the casting sequence. The infrared value being measured drops when the skin of oxide cracks. This change is detected by the sensor and the right moment for casting calculated by the microprocessor. The signal indicating readiness for casting is given, and casting started as soon as the casting temperature is reached. The crucible opens and the melt flows into the muffle. Only then is the vacuum released and the melt forced into the muffle under a positive pressure. This ensures it reaches even the most minute cavities in the muffle quickly, yet in a controlled manner. Whatever the casting technique, the muffles must be cooled slowly to room temperature after casting. This avoids inducing stresses in the metal as a result of cooling too quickly. Only muffles that have cooled down completely can be immersed in water to avoid dust during deflasking. The casting is now released carefully from the muffle. A small deflasking chisel or a hammer applied to the casting cone is a suitable tool. The investment is removed in this way without damaging the casting. To make blasting easier and quicker, as little investment as possible should adhere to the casting. The investment and the oxide layer are now removed with pure aluminium oxide in the form of Corox 110, in this case, at a maximum pressure of 4 bar. Critical areas, such as the insides of clasps and stabilizers, are blasted with Corox 50 at reduced pressure. Cobalt chrome frames can be blasted manually or automatically with the Aquamat wet blaster. The wet blasting technique gives a silk finish and lower surface roughness than blasting with dry corundum. The important thing is that absolutely no dust can be generated. Here, where accuracy is what matters, directed blasting is carried out with the fine jet pencil, first with 50 micron aluminium oxide and then with 50 micron perlablast. The sprues are separated safely and faster on the high-speed grinder with built-in extraction system. Here, small separating discs with a diameter of 25 millimeters and a thickness of 0.5 millimeter are used. Once the chuck has been released, the tool can be changed quickly without having to switch the motor off. The fixing points of the sprues are ground with a perforated disc. Finishing can be completed with the high-speed grinder or the handpiece. Sintered diamond grinding stones have proven very effective for finishing cobalt chrome alloys with the handpiece. Diamond grinding stones are much more cost-effective than ceramically bound stones. In the interest of safety, the maximum speed of 30,000 revolutions per minute must not be exceeded. The dorsal finishing line is smoothed with a fine-grain grinding stone or, as in this case, with a sintered diamond one. When using sintered diamonds with a diameter of more than 5 millimeters, the speed is reduced to 10,000 revolutions per minute. The finishing lines must be demarcated carefully. The tips of the clasps and the rests should be rounded slightly. Critical areas between clasp elements can be separated with a small separating disc or a sintered diamond point. Clear demarcations must be created with the sintered diamond point in order to achieve a transition without gaps between the metal base and the acrylic saddle to be fitted later. To avoid impairing their shape and stability, small, very carefully modelled supports should only be finished with the rubber polisher. When stippled surfaces, such as this base, are finished with a blunt carbide rose drill, electrolytic polishing is more effective. Blasting with fine aluminium oxide and perlablast before polishing improves the surface finish on the insides of the clasps and rests and enhances the final polish. The object is secured with an alligator clip and attached to the moving anode. An additional cathode can be attached to polish the stippled palatal area adequately as well. The tip of the curved copper rod is fixed at the lowest point of the upper base without coming into contact with it. Firm and secure contact is important for a good result. The cobalt chrome frame must not be in contact with the negative pole, that is, the cathode. Otherwise, an overcurrent will flow, causing the unit to switch off. Bego will take used Wirolite polishing liquid back on payment of a charge for disposal. The Ultrapole SL has 3 current settings. Polishing for 4 minutes with a current of 6 amps and a bath temperature of 40 to 60 degrees Celsius gives a good result. Further polishing is not required. Electrolytic polishing removes roughness in the form of minute edges and tips. Excessive polishing jeopardizes the fit and dimensional accuracy of the clasps by removing too much material. It is advisable to work with a masking lacquer such as Seculac on critical areas such as stabilizers, female part holders, delicate clasps and rests. It's applied sparingly, dries rapidly, and is easily peeled off after polishing. No material is removed from the masked areas. After polishing, the cobalt chrome frame is rinsed and thoroughly cleaned with the steam cleaner. The frame is now placed on the model. Sprinkling talcum powder on the plaster teeth allows the polished frame to slide onto the model easily. Here a duplicated working model made of Bago stone is being used to avoid damaging the master model. This enables the dentist to better evaluate the design and effectiveness of the prosthesis on the undamaged master model. The frame is now removed from the model and reworked here, where there is still slight interference, using a fine-grained sintered diamond or rubber polisher. Only the bottom edge of the clasp is rounded with the rubber polishing roller. The accuracy of fit, and hence the retaining effect of the clasp, is reduced every time material is removed. Base, sublingual bar and minor connectors are smoothed with a small rubber polishing wheel or rubber roller. Outside surfaces of clasps and rests are rubber polished with a green soft rubber polishing point. Separated or relatively inaccessible areas are rounded with a knife edge wheel or small wheel. The basal surface of upper frames is only rubber polished in exposed or concave areas. A surface with a lasting high polish can be achieved with a medium hard polishing brush and small amount of cobalt chrome polishing paste. Areas that are difficult of access can be polished with a small stiff brush with a metal hub. To avoid scoring, the direction in which this polishing is carried out must be constantly changed and the frame supported securely. The handpiece brush can be used with cobalt chrome and diamond polishing paste, as shown here, to improve polishing of metal masticatory surfaces or backings. Finally, the frame is high polished with soft linen. The surface consolidated in this way prevents plaque building up. The cobalt chrome frame, which has now been polished, is cleaned thoroughly with the Triton steam cleaner. The frame is now placed on the master model and checked for accuracy of fit. The tip of the clasp chafes at this point when the frame is placed on the plaster model. The clasp bends up here at the natural tooth and slides over the greatest diameter into the retention area. Since clasp protheses are not secured on the remaining dentition as firmly as attachment or telescopic work, clasp arms, rests and the base must fit accurately without inducing stresses. It is evident on the master model that the dental design of the prosthesis meets the requirements for maximizing the exposure of the periodontium. This upper and lower archwork for patients, which has already been shown in the preceding parts of the video, can now be inserted by the dentist as a frame at first, and then with wax rims for registering the bite. The minimum gap of 4 millimeters required between base and marginal gingiva has been achieved. The dentist checks the fit of the frames and the bite situation in the patient's mouth. The shape and size of the rests and clasps are planned out to avoid impairing the articulation. The physical properties of the Bego cobalt chrome alloys allow slender clasps. They are characterized by particularly high ductile yield in conjunction with high strength. Even in the case of combined work, as with the Ancora rod attachment here, a functional tooth replacement that fits accurately is no problem using the Bego system. The rigid connection between the saddle of the prosthesis plus the base and the remaining dentition is provided here by a sublingual bar made of Wironit extra hard. On the primary frame made of Wiron 99, milled shoulders and an interlock hole are provided to guide and support the prosthesis. The Ancora rod attachment is a rigid extracoronal profile rod attachment for partial prostheses. The replaceable female parts are elastic and extremely tough. The interlock hole opening in the basal direction has proven very effective from the point of view of hygiene. The stabilizer is shaped anatomically. The pontic-like shape of the first replacement tooth exposes the periodontium. The cavity for the female part holder has been blasted with fine aluminium oxide and masked with Seculac for electrolytic polishing. This is important in ensuring the female part holder seats accurately. It is pushed into the holder with the impression pin. It's also possible to leave insertion of the female part until the cobalt chrome work with teeth and acrylic is completed. Thus, it is possible, with carefully tailored process technology and appropriate materials and equipment, to achieve reliably reproducible results. The work is finished in the dental lab and then inserted by the dentist.